Welcome to the second part of the NBT preparation tutorial. This is just a continuation video of the part that we did questions 1, 2, 3 in the last video. So let's finish off the other question. Now, question 4 says, if the graph of y equal negative x squared plus 6x minus 5 is reflected in the x-axis, and the resulting graph is then reflected in the y-axis, the new equation is. Right, now let's see what it means to reflect an equation algebraically. This part we will write reflecting about the x-axis, and here we're going to say reflecting about the y-axis. Right, let's say for example we have y equal ax squared plus bx plus c. When we reflect about the x-axis, we put a negative in front of the y. In other words, a reflection about the x-axis makes us to put a negative in front of y. Now, reflecting about the y-axis makes us to put a negative in front of x. This is very important because we'll be using this as we try to solve this question. So when we reflect about the x-axis, we need to put a negative in front of y, or we need to multiply y by a negative. And when we reflect about the y-axis, we need to multiply all the x's by a negative. In other words, if we were to reflect this equation about the x-axis, we need to put a negative in front of y. In other words, this is the same as negative y, which implies that we put a negative in front of ax squared plus bx plus c. In other words, the new equation, let's call it h of x, will be negative a squared minus bx minus c. So this is the new equation that is reflected about the x-axis. So we multiply the whole y by a negative. So if we were to reflect this about the y-axis, we would have to put a negative where x is. In other words, we have y equal ax squared plus bx plus c. To put a negative where there is x, in other words, we're going to, let's say h, we're going to have a and then negative x squared. Let me erase this, it's not nice. Negative x squared plus b, and put a negative on x plus c, which now then becomes ax squared because the negative gets cancelled, negative bx plus c. This is what happens when we reflect about the y-axis, and this is what happens when we reflect about the x-axis. Now, let's see what we have. Let me try to erase this real quick. Now, here's what we have. We have y equal negative x squared plus 6x minus 5. They first say this equation is reflected, this graph is actually reflected in the x-axis, which means we are multiplying y by negative 1, right? So in other words, if we're reflecting about x-axis, we put the negative to y. So in other words, we're going to have negative y, which is the same as putting a negative into everything. So this is negative x squared plus 6x minus 5. And now it means, let's say, h of x becomes x squared minus 6x plus 5, right? And then they say this resulting equation, this resulting graph is then reflected in the y-axis. The new equation is to reflect about the y-axis, we put a negative on x. In other words, we're going to look for h of negative x. In this case, we're going to have negative x squared minus 6 into negative x plus 5. And then let's call this g of x, the new equation. We are going to get x squared plus 6x plus 5. Now let's see if we have we have D right there, which is our answer. Right, question 5 says, for any real number x, which one of the following statements is always true? It's very important for the always part. They actually bolded it to make sure that you know that it's very imperative that always true should be the case. Now, these kinds of questions are what we call trial and error questions. This means that we need to try each and every choice to see if it satisfies this always true condition. Let's first try A. So A says negative x less than 0 is always true. But is this always true? Think about it. You can try to think about it. You can pause the video and think, is this always true? Well, if you did try it, this is not always true. Now, let me give you a reason why. We know that if x, let's say x was a set 1, 2, and maybe to positive infinity, we know that we could have 1, which is less than 0, negative 1, which is less than 0, and we can also have negative 2, which is less than 0. But what if x was a set of negatives? In this case, negative 1, negative 2, up to negative infinity. In other words, we were going to have negative 1, which is positive 1, and positive 1 is greater than 0. And if we were to have negative 2, we would get 2. 2 is greater than 0. So it means A is not always true, because we found some x values where x is false, right? So that is a mathematical term. If you will be doing discrete mathematics in varsity, we will do this kind of stuff. But as long as we can find at least one value that makes this to be false, then we can say it cannot always be true. Because it is true when x is positive, but when x is negative, then the whole system breaks, right? Which means A is actually wrong. We can discard A. Now for B, let's see. B is rational. Do you think 1 over x is always rational? Think about it. Because a rational number, remember, is any number that can be written in this form given that b is not equal to 0, right? So, well, we can have x as 0. In other words, you can have 1 over, for example, let's start with 1 over 1, which is 1. It is rational. But 1 and also 1 over 2 is 0.5, which is rational, and 1,3, which is 0.33 recurring, which is also rational. But what if we had 1 over 0, right? So it means it cannot always be rational, because there exists at least one x value, which is 0, which breaks the whole system, and also b is incorrect, right? Let me erase this so we can try C and D. Let's see if C is always true. Now we have x plus 1 less than 1. Let's take 1 to the other side. We have x plus 1 minus 1 less than 0. Now we are trying to find the validity of this. So this is actually the same as this. So is this always true? Is this always less than 0? Now let's test it. Let's give it a set of numbers. Let's say let's choose a random numbers. Let's say x is an element of these random numbers. Let's say -1, 0, let's say 4 or 5. If we can find at least one of these that is greater than 0, it means it's not always true. Right now, let's try -1. -1, we have -1 plus 1 less than 1. I mean minus 1 and then less than 0. Well, this breaks the system because this is neither less than 0 or greater than 0, which means it's not always true. This system is not always true because this breaks the system. This -1 divided by 0 makes everything breaks, right? So this is not always true. And let's say we wanted to try another one. Let's try x negative 5. I know it's not in this set, but we just chose random numbers, right? So let's try x being negative 5. So in other words, let's say negative 5 plus 1 minus 1, right? So negative 5 divided by negative 4 minus 1 gives us 5 over 4 minus 1, which is 1,25 minus 1. And 1,25 minus 1 is 0.25, and 0.25 is greater than 0, which means this system is wrong. So we now know that A, B, and C are wrong. D can be our answer, but let's check if it is true. Right now, let's test D. D says 1 over x is always greater than 1, given that x is between 0 and 1, right? Now let's test this. This we don't have to take 1 to the other side. It's actually simpler this way, right? So now let's test it. Let's take 0.1 as x. 0.1, that is going to be 1 divided by 0.1. 0.1 goes 10 times to 1. This is actually 10, and 10 is greater than 1, which is true. So let's try 1 over 0.9. 1 over 0.9 is actually 1,11111 recurring. So 1,111 recurring is actually greater than 1. Right? So we took 0.1 and 0.9. Let's try maybe 0.5. Let's divide this by 0.5. We have 2. And 2 is greater than 1. And let's try dividing this by 0.25. 0.25 goes 4 times into 1, which means the answer is 4, and 4 is greater than 1. So we can see that D is actually the correct one. Now, again, due to the video getting a bit longer and I'm trying to keep my videos a little bit shorter, I'm going to end this tutorial here, and I'll finish off the next questions in the next videos. So see you in the next video.